It really is focused on making the worker's life easier, but you have to convince them of that. They're in the end, they're the customers that we're delivering to, the workers on the shop floor. So we definitely have change management in mind as we're going through this.
Hello, welcome to Coffee with Mr. IoT. My name is Robert Schmidt, also known as Mr. IoT. Today, my guest on the show is Pierre Harter, Director of Advanced Manufacturing Strategy at Spirit Aerosystems. Did I say that right?
You did. Thanks for having me.
Thanks for being here. It's great to have you. Spirit Aerosystems. Tell us a little bit, because you're not the airline. Sure. It might be worthwhile just explaining what you do.
Yeah, so Spirit Aerosystems, we're the world's largest Tier 1 aerostructures company. We've got 7 locations worldwide. We did about $7.2 billion in revenue last year. We have, and by large aerostructures, I mean we do for instance, on all the Boeing airplanes, 737, 67, 777, 87, we make the Section 41, which is the forward portion of the airplane, the nose. 737, we do the entire fuselage. It ships by train.
So I sat in one of your structures today.
You did. If you flew here, you likely flew on something that Spirit builds. So we do fuselages is about 50% of our revenue, and that's forward, mid, and aft fuselage portions. We also have 25% roughly of the revenues in propulsion, which is pylons, so what holds the engine onto the wings, thrust reversers, engine cowlings, and then the other 25% is wing. So we do leading edges, trailing edges, control surfaces, those type of things.
So I'm curious, right, when I fly, I don't get to see what the structures are made out of. And there's, I know all planes were built out of aluminum. What are you building out of today? What's still built out of aluminum? What's built out of carbon fiber? Give us a little bit. Let's geek out just a little bit. I'd love to hear.
Great question. So the legacy airplanes, if you will, the 737, the 67, the 47, those are all metallic structures.
So it's not even aluminum.
It's aluminum.
Oh, it is aluminum.
There's a lot of aluminum. So the skins are aluminum, stringers, frames. There's also stainless steels in there, titaniums, those type of things. The newer airplanes, the 787, Airbus's A350, are composite carbon fiber skinned airplanes. So those we use automated fiber placement. So these are big machines that lay down strips of carbon fiber to build those airplanes. Those airplanes, they're called composite airplanes because the outside, the skins are composite, but there's still a lot of metallic content on the inside. So you've still got a lot of aluminum. A lot of times aluminum and carbon don't do well together from a corrosion perspective. So when you have metal touching composite, a lot of times you have titanium in there because the titanium is good galvanically compared to carbon. So a lot of titanium and aluminum and steel still even in those carbon airplanes.
So I gotta assume shifting from metallic, as you call it, to carbon fiber must be a big change for production and you in manufacturing. How big was the change? What does that mean for a company like yours to go through a transition like this?
Yeah, so it's a new competency. It has to become a core competency for you. So that was a big transition going from metallic to carbon. A lot of differences in the manufacturing process of the basic fabrication. Once you get up to the assembly, though, there's still a lot of similarities. They're still bolted together. There's different types of bolts, but still bolts, still drilling holes. So some of those things transfer, but there was certainly a lot of new competency that had to be developed for those new airplanes. So
I just got a pilot's lessons, and so I'm watching a lot of YouTube on how people building planes. And there's also this whole sort of like, oh my God, do I want to step in a plane that someone drills a hole in? And you're talking about bolts and stuff like this, but actually there's a lot more to, and this goes into what you call the factory of the future, right? But you're not just bolting stuff together. I mean, there is certain specs and there's a whole lot of stuff that goes on. Can you tell us a little bit about that? Otherwise I just feel like I'm sitting in a garage and bolting something together with my wrench, which that's not what it is.
There's a lot of fasteners in airplanes. And just the fuselage that we build, there's over 250,000 rivets and bolts. Yeah, per airplane, so a lot. I would say on our legacy airplanes, on the metallic ones, about 50% of those are automated. Where we have big automated fastening machines that go in there, drill the holes, and fill them. We call it drill and fill, but that's essentially putting in the rivet, and rivets then get bucked. We call it bucking the rivet, where you squeeze the rivet. In some cases, in a lot of high load areas, those type of things, a lot of times we'll use different fasteners, so bolts that are fastened in there. So again, about 50% of that is automated, so very, very high quality, very repeatable.
Lots of consistency, and you know exactly
Yep.
what pressure these rivets can take and how they respond. And so
Yeah, and so all the OEMs have specs for everything we do. There's specs for sealing, there's specs for putting in fasteners, there's specs for torquing, so everything is rigidly controlled and documented, and of course, you know, with the flying public in mind, everything's double checked with quality.
when there's a logbook actually that has to be kept throughout the production of a plane, right? So, I mean, there's a lot of history that we don't know when we step on a plane.
Yeah, absolutely. Every part has its own, you know, from the raw material that's received, there's certification that the strengths are what they're supposed to be, and then as the parts are made, there's a traceability, part records, quality records that go with every single part, even down to those little rivets.
Those little rivets, 250,000 of them.
Yep.
So, the Factory of the Future, tell us a little bit about it. It's a project that we're doing with you. Tell us a little bit about it. What is it about? What are you trying to achieve? And what's really the change for me as a passenger out there in one of the structures you make?
Sure. Fundamentally, the flying public won't really see a change. The structure is going to be the same. It still has to meet those exact same specs. But what we're doing is really focused on making life easier for the shop mechanic. That's really the best way to distill it. You know, in the old way of doing things, we had, like I said, we had about 50% of the fasteners on those metallic airplanes are auto fastened, but there's still 50% that then means there's manual labor involved. But either way, manual or auto, there's still a lot of time spent by the mechanics, by the leads, searching for parts, finding out where their part is, what's going to go on the machine, at what time, those type of things. So we're trying to digitize that and add a digital thread all throughout the factory. And that's really where we asked Deloitte to come in and help us on an application that we've now named Floor Sight. And so
Floor and sight.
Floor
like
and sight
the
together.
Shop floor and the sightseeing.
Exactly,
Okay.
exactly. So we piloted it. The pilot began in April of this year, 2019. Went pretty darn well. We did it in a localized area.
What's pretty darn well? What does
pretty
that?
darn
How
well
do you
meaning-
measure darn well? I love it. It's sort of like but I'm curious how you think about darn well.
It's you know, with anything in new technology, it takes a while for the people that are using it to really understand what it's taken. But yeah, change management was critical there. But we got a lot of great feedback from the industrial engineers that were the ones that typically would come in early in the morning, you know, spend a couple hours looking at master schedule requirements, finding out what part availability was, and then trying to merge those together to create a plan of the day. And of course, everything was done spreadsheets or handwritten, and they create a plan of the day for the machines. And then 2 hours later, they come back, and of course, you know, don't have this part or something happened on the machine and have to redo everything, and then come back at lunchtime and update the plan of the day. And at the end of the day, plan goes in the trash, and you come in the morning and start all over. With Floor Sight, what we developed is a couple different things. One, we're using RFID tracking so that we can track parts as they're coming from the kitting area to the machines and throughout the floor, so we understand exactly where parts are.
So the part has a little tag on it.
Yep.
And you have sensors or antennas really inside your factory floor that tracks where every part is at what point in time.
So we have a gate when it leaves the kitting area. We've got a gate into a staging area near different, and there's a couple different machines that we have these on, 8 different machines. There's a gate when it goes onto the machine, so we can know that it's on the machine, and it comes off the machine. So we track all that, so we have transparency for the mechanics and for the supervisors of exactly where their parts are. We've tapped back into our 3PL provider, so we understand part availability at in the warehouse.
So the third-party logistic provider that
Exactly.
helps with getting everything there. Okay.
Exactly. So we can tap into and understand exactly where parts are. if there's shortages, and we can see, hey, maybe there's a part in stock, those type of things.
Can you switch parts when one part is not available? Sometimes, not always.
You can't switch parts. You would have but we do have workarounds. So if if a stringer is not available or something happened to it, is damaged or something like that, and it can't be auto fastened on the machine, you do what you can on the machine, and then you travel that work to a different station and do the work there.
So, this sounds like an amazing. What's your role in all of this?
So I'm Director Advanced Manufacturing Strategy. So that's really our term for Factory of the Future. We actually.
So it's your baby. It's your brainchild.
Yeah. So I'm the engineering director. I have a counterpart who's runs our integrated product team, IPT. So I've got the industrial engineers, the principal architects that are really the solution architects for these things, and then we have a bunch of different partners like Deloitte and others, machine suppliers, automation suppliers that we've brought together under the umbrella of a collaboration agreement. We think is pretty unique, where we can all work together to get the best of all the different parties, as opposed to creating a machine spec and throwing it over the fence and see who comes back with the best bid. We're able to take bits and pieces from different companies and combine them to a better overall solution.
Yeah, I often say IoT is a team sport, right? And so it seems like you have made some interesting collaboration agreements. What did you do to make us all work together with each other? What were some of the few tips you'd give someone that wants to go down that road?
So it took us a while, and we've been on both sides of these type of arrangements with our OEMs. And then we created this one where we're kind of on the other side of the fence, where we're the ones benefiting. But it has to be a partnership, first of all, so everybody has to get something out of it. IP is always at the center of these, intellectual property is always at the center of these agreements, so we had to come up with I'd say somewhat unique ways of handling IP. So we took a lot of learning from that pilot, good feedback, but it didn't have everything that the shop floor needed. And we had some, it was a pilot, so it didn't have everything. We didn't have all the right connections to our internal IT. So we had to go through a tunnel and didn't have real-time feeds of data and couldn't read directly from SAP and those type of things. So we took those learnings, we did a version 1.5 in the summertime, and that got really well received. And we started seeing benefits, 30% less time people searching parts in the day. Machine utilization has gone up by over 10%. So really good things there. So now we're working on 2.0, Floorsight 2.0. We just started on that, and that is basically taking what we developed for those 8 machines and exploding it outward. So we're going downstream back into the skin fab area before it gets fastened, and then we're also taking it upstream. So after we've created skin panels, then you start assembling them into a tube, essentially. So we're taking it upstream to those assembly areas as well.
So I want to just re-say some of the things because they fascinate me. One of the things I heard you say was it's not good enough just to have IoT as the machine, put some sensors on it or track stuff. You got to connect it with what already exists, your ERP systems and so forth. And you learned that through your pilot and changed that, and that made a big difference is what I heard.
It did, yep.
And then I heard also you saying you increased your machine utilization by 10%, which is also amazing, or over 10%. Does that mean actually you're making those structures faster now? It takes less time?
I would say we're reducing the amount of non-value added time in the system. So machines are still, putting a rivet in every 5 seconds. That doesn't go any faster. But what we're reducing is the amount of time the machine's sitting there waiting for a part, which is key. There's a lot of time.
Which means you can make more.
Right. You can make more overall.
How long does it take to make one of those parts?
Those machines, we're talking about, a 40-foot long panel and, about a quarter of the airplane, a tube like that. Those have run times anywhere from 4 to 7 hours.
It sounds like an amazing job.
It is. It's really cool.
Yeah, I mean, it's very cool. You've been in the airline business for quite a long time. How do you get a job like this? Can you tell us a little bit about your history, your start? You told me about a startup story. That's really fascinating. Love to hear about that a little bit.
So as we spoke before, I grew up in Kansas, went to Wichita State University, go Shocks. And we.
Are they doing good this year?
So I did. Yeah, we got a good basketball team. They're young, but they're doing pretty darn well. So did my bachelor's and master's in aerospace engineering. While I was there, I worked at a institute on campus, the National Institute for Aviation Research. I worked in the composites lab, so I'm really a composites guy. So I left school, I went to Denver, went to a startup company called Atom Aircraft, and spent 9 great years there, really learning. I was employee number 6, and we got up to over 1,000. So I got to learn how to grow a company and how
You
to
built an
design
airplane,
airplanes.
right? I mean,
yeah.
you designed
oh, yeah,
and
we
built one.
designed clean sheet, designed, certified through the FAA, started delivering to customers. So it was a 6-seat, small airplane, 6-seater, pusher puller. So it had 2 engines, but they were on the front and the back of the fuselage. So tail booms, really neat, mostly composite airplanes. So
Do they still fly?
there's a couple of them still out there. Yep. And then we that company, we did great, but eventually through the financial crisis went under. So I did a little bit of consulting, and then I came back to Wichita. I got married, and my wife and I are both close to our family, so we came back home. Worked at Learjet for about 6 years, and then moved over to Spirit.
So you went bigger and bigger and bigger planes in a way.
I did, and I went from composites and new product development for most of my career. Just developing new airplanes, not really working on the manufacturing side of things, but designing and certifying. And then I went to big time production rates at Spirit, and it's been a great journey. So learning a completely different side of the business.
And you said you're not a pilot, right?
No, I started taking lessons, so I know how to fly, but I don't have my license.
I always thought everybody who works there must be a pilot because they're so excited about it. Is that sort of like, you think you're going to become a pilot at some point, or you kind of like so much around airplanes that you don't want to do anything with it anymore?
No, I think I will eventually. Once the kids get older, I think I'll have a little time to get that license.
So I wanted to sort of close out talking a little bit about where do you see this go? I'm almost kind of like wondering, when you've been now, you're on 2.0, you've gone through the very early parts of it, you've learned. Where do you see this go in a couple of years? What are you missing? And how do you deal with the change of this, right? I mean, there's always talk when automation happens, what happens to employees, how do they feel, and so forth. So can we talk a little bit about the soft factors around this?
Absolutely.
And where do you see it going?
Yeah, we talk about it all the time, actually. It's, I tell people not to downplay the technical things that we have to overcome, because there's certainly technical challenges, but I think the bigger challenges are the change management or the cultural change that has to happen as you bring in automation.
So technology isn't really the challenge anymore for you?
It's out there for the most part and being used. The challenge is finding ways to make it useful in aerospace, in the manufacturing environment, which certainly has its challenges with part size and part count and those type of things. So there's certainly challenges in augmenting those technologies and bringing different pieces together and making them work in aerospace. But it's, as any change, we're fundamentally trying to change the way we build airplanes through automation, and it really is focused on making the worker's life easier. But you have to convince them of that. They're in the end, they're the customers that we're delivering to, the workers on the shop floor. So we definitely have change management in mind as we're going through this.
Looking out a few years, what are you thinking?
So floor site, we're like I said, we're expanding it into more and more of the factory. We've already got areas of the factory that don't have it, that have seen it
And
have started wanting it. So
that's excellent.
That's a great part of the change management. We've noticed that people downstream of the machines that are in the part kitting area are actually looking at the app and looking at the areas that their customers are, that they're delivering to, and starting to see things through their eyes. So we thought that was really neat. So we want to expand it throughout the factory and to different buildings as well. We've got over 12 million square feet of space at Spirit at 6 different sites, and just at the Wichita, the main headquarters, we're almost a square mile of different facilities there. So there's a lot of different places to move the application.
Well, thanks for being on the show. I really appreciate
You're welcome.
it.
It was great. Appreciate the
I
opportunity.
got on planes all day long, and so it's great to meet you. Hopefully, I get to stop by.
You need to come to Wichita.
Yeah, I'm actually in Wichita the week after next. So, yeah,
Well, you got to come by. You know how to find me.
I know how to find you.
I'll give you the tour.
Awesome. Thank you. And with that, we have another Coffee with Mr. ID coming to an end. Thank you for watching. If you missed part of today's show or any past shows, please check out the playlist on YouTube. Search for Coffee with Mr. IoT. And with that, have a great day. Bye.